This is Mr. Martin. This video is covering section 3.2. We're going to be looking at logarithmic functions and their graphs for Precalculus Honors. So let's take a look at the definition of a logarithmic function. So for x greater than 0 and a greater than 0 and a is not equal to 1, we have y is equal to log base a of x if and only if, the symbol is if and only if, x is equal to a to the y. And we're going to use this definition also to switch between forms, and we'll do that in example 1 here to make things a little bit easier for us. So for part A, if x is equal to 16, so we're going to substitute that in, and I'm going to flip things around. So I've got the log base 4 of 16, and I'm going to let that equal to y instead of f of x, just to simplify things a little. And then I'm going to change my form, because we could go from one form to the other. So now what I'm going to do, so basically this base is still going to become a base when I write it as the exponent, or when I rewrite this in exponent form, and then the y is going to become the exponent. So when I rewrite this, I'm going to go 4 raised to the y is equal to 16. So here's what it will look like. 4 raised to the y is equal to 16. So that's just changing it from one form to the other. So now we need to ask ourselves 4 to what power is equal to 16, and y is equal to 2. Alright, for part B, again, I'm going to let this equal y, and I'm going to rewrite it. So the 5 still becomes the base. So 5 is our base, y becomes our exponent, and it's going to be equal to 1. So 5 raised to what power is equal to 1, y has to equal 0. Alright, next one, again, I'm going to let this equal y. So 3 to the y is going to equal 1 over 81. So we need to ask, what exponent do I need to raise 3 to so that I get 1 over 81? Well, I know that 3 to the third would be 81, so then 3 to the negative third would be 1 over 81. Remember, with that negative exponent, you just flip it to the other part of the fraction. Alright, and then for part 2, we're just going to calculate these on our, evaluate these on our calculator. So if you remember from algebra, anytime there's no base down here, if you notice none of these have a base, the base is going to be 10. So when we leave it out, it's assumed to be 10, and on our calculator, that's what this log is over here. So for this, we're going to do log of 10, and again, since there's no base there, it's assumed to be base 10, and that's going to be 1. And for the next one, we have log of 3.4. So that's 0.5315. And let's do the last one. We have the log of negative 3. And notice here we get an error message. So let's take a look at that. So what this is saying is, let's let this equal y. And then this is our base 10. So let's rewrite this in exponent form. So 10 to the y is equal to negative 3. So what this is saying is, what exponent can we raise 10 to and get a negative number. Okay, that's basically what this statement here is saying. And really, there is no exponent that we can put in here and end up with a negative number. So none, which is why this problem here is undefined. Okay? All right, so properties of logarithms. So log base a of 1 is equal to 0. Again, if we think about this, rewriting it, a to the 0 is equal to 1. Any number raised to the 0 is equal to 1. Log base a of a is equal to 1. Again, rewriting it, anything to the first is just going to be that number. Then we have log base a of a to the x is equal to x. And if we rewrite that, we would have a to the log base a of x is equal to x. Okay, so this is called the inverse property. And then number 4, if log base a of x is equal to log base a of y, then x is equal to y. That's called the one-to-one property. So let's move on to example 3. We'll use some of our log properties here. For part A, we have log base 4 of x is equal to log base 4 of 14.3. So we'll use our one-to-one property, and x is going to be 14.3. Part B, we have log base 3 of 3 is equal to x. So we're going to use our second property here. That's just going to equal 1. And again, you could rewrite this if you wanted it to, so it would be 3 to the x is equal to 3. So if I want to put an exponent here, it would just be 1, so x has to be 1. And for part C, this is our inverse property, so 12 raised to the log base 12 of 5 is just going to be 5. So make sure you learn those properties so you can apply them. All right, moving on to example 4. We're going to take a look at a graph of y equals 3 to the x and its inverse, log base 3 of x. So these are inverse functions. All right, so if you recall, inverse functions, graphically, they're going to be reflections over the line y equals x. So another way to think about that is that the x and y coordinates just switch with each other. So let's take a look at y equals 3 to the x, and let's make a table of a few values so that we can graph it. So let's look at -2, -1, 0, 1, and 2. So using a calculator to figure this out, I've got 3 to the -2, so that's 1/9. Or if we want to use decimal, it would be 0.11. 1/9 if you prefer. 3 to the -1 is going to be 0.33 or 1/3. 3 to the 0 is 1. 3 to the first is 3, and 3 to the second is 9. So let's go ahead and graph these. I have -2 and 1/9. So somewhere about there. -1, 1/3. 0, 1, 1, 3, and 2, 9. I believe that's right there. So let's go ahead and connect these. So it's going to look something like this. Okay, we'll make that as smooth as we can going through those points. Now, for this, since these are inverses, we're just going to switch all the x and y values. So now my y values are going to be -2, -1, 0, 1, and 2, and my x values are going to be 1/9, 1/3, 1, 3, and 9, and we'll go ahead and graph those. So I have 1/9, -2, and 1/3, -1. Let's fix that point there. 1/9, -2, 1/3, -1. Kind of estimating there. 1, 0, 3, 1, and then we're going to have 9, 2 over here, and we'll go ahead and sketch in a smooth curve for that, and it should look something like this. Come on back. There we go. Alright, and you can see that these are reflections of each other over the line y equals x, which they should be because they are inverses. Alright, let's look at another graph here. We're going to graph the following by hand, and we're going to use our transformations to help us with this. So let's let this equal y. So I've got y is equal to log base 10 of x plus 2 minus 4. So what I'm going to do is I'm going to find the inverse function of this because that'll be easier to calculate values. So I'm going to solve this for x. So I'm going to add 4 to both sides. So I have y plus 4 is equal to log of x plus 2. And again, this is a base 10 here. So I'm going to go ahead and rewrite this in exponent form. So I'm going to have 10 to the y plus 4 is equal to x plus 2. And 10 to the y plus 4 is equal to minus 2. Minus 2 is equal to x. So typically when you do this, you'll flip-flop the x and y and then solve it back for y. So we'll just do that in the last step here. So then my inverse function becomes y is equal to 10 to the x plus 4 minus 2. So this is our inverse, and let's take a look at some values for this inverse function. So let's take a look at some convenient values. So -5, -4, -3, and -2. And the reason I'm choosing these is when I go ahead and substitute those in, I'm going to get some reasonable values for my function here. So when I plug in -5, I'm going to have 10 to the -5 plus 4, so that's 10 to the -1, so that's 1/10. And then minus 2, so that's going to give us -1.9. And then when I plug in 4, that's going to be 10 to the 0. So that's going to be 1. So I have 1 minus 2, which is -1. Plug in -3, it's going to be 10 to the first minus 2, which is 8. And then -2, so that's going to be 10 squared is 100 minus 2, which is 98. We're not going to graph that one. So let's take a look at these points. I've got -5, 1.9. So that's going to be about here. And -4, -1. Whoop, let's fix those. -5, -1.9. And -4, -1, -3, 8. All right, and that looks like that's all we're going to get. All right, and let's connect those with a curve. So it's going to look something like this. It's going to go up here in a hurry. And again, when I graph the original function, the log, it should be a reflection over this line y equals x. So I'm going to go ahead and take my table of values and just switch the x's and the y's. So x, y. So now my y values are -5, -4, -3, -2, and then -1.9, -1, 8, and 98, which again we're not going to graph. So then when I go ahead and I graph these, so I have -1.9, -5, so somewhere around here, -1, -4, 8, -3, and we'll connect those with a smooth line again. Coming over this way. And again, you can see that they're reflections of each other over y equals x. And there's the graph of log of x plus 2 minus 4. All right, so that's the end of this video. Go ahead and try the checkup. And I should have the solution for the checkup in class if you want to see how you did. As always, if you have questions, make sure you get those answered, and we'll see you next time.